Okay, I have 5 minutes to explain to you why you should get modeling if you don't already, and to show you some of the things you should be doing. Well, what is a data model, is it? Just a diagram? Lots of people think it is. I've got a data model. It's that big, huge poster up on the wall. That's my data model. No. That's just a visualization of your data model. The data model is a lot more information than that. It's like saying a screen print is my database. Of course it's not. We have all sorts of stuff here. We have domains, tables, references, views, table spaces. If you look at the middle here, we've got definitions of a couple of tables. We're looking at the SQL preview that would be generated from the metadata for table ISIS tab, and for this other one, JDBC function columns, we can see a list of columns. We can see so many tabs there. We can define indexes, keys, triggers, procedures, PostgreSQL stuff, mappings, permissions, physical options, and even attach some standard scripts. There's a lot more than just a diagram to a data model. Right, Simon and Hannu in their wonderful book on page 59 said when you plan a new database you should design the structure and estimate the size. This is an iterative process. It's best done with a data model. With a data model you can apply version control, you can compare model to database, you can compare model to model, model to script, work out what the deltas are, customize the script so you generate the exact script that you actually want. You can automate tasks. You want to migrate from Oracle to PostgreSQL? We can automate that, or make life a lot simpler. You want to reverse engineer from a database? We can do that. WSDL? Yeah. XSD? Yes, we can do that. You reverse engineer an XSD, create a model, perhaps then create a physical data model from it, create a database design to store that WSDL or XSD data in it, create logical and conceptual views, generate stuff from here as well, generate those XML schemas, generate your object model. So when you're validating, you could use standard model checks, create your own model checks. There's some here I've added, but you can't tell the difference between them and the ones that came out of the box. Enforcing naming standards using a glossary. Enforce the naming standards for your indexes, constraints, whether or not you get indexes, when you get indexes. Express what all those default options are. Create or update your database and customize the scripts, as I already said on the previous slide. Model and generate an OLAP. Take a relational design. Figure out what the candidate facts and dimensions are, generate a dimensional model from that, and from that generate and build your OLAP cube, and generate the scripts to move the data from one to another. Fine. Well, Simon and Hannu also say you need to understand database dependencies, and they illustrate that within the database, running some queries against the database catalog, if that's what you call it in PostgreSQL. I can't remember. So, look, tables use views, and views referenced by procedures. Fine. Well, you can do that in models as well. See here, there's the impact analysis for a particular view linking to other views and through those views to other tables. If I wanted to, I could actually say hide those intermediate views. All I'm interested in is knowing which tables this view gets data from, and therefore which views are affected. If I go backwards the other way, if I change the table ISysDomain, I know it affects the SysDomain view and the SysTypes view, and probably other things as well. And what about other dependencies, the ones that aren't in your database? Your SQL would never tell you that. What about the ETL jobs that rely on structures in your database, the forms and reports that have that data in them, the applications that are interested in, the message schemas, the regulatory requirements that affect it, which business processes create the data, which use cases describe how we access the data, which JIRA tickets actually tell us what's wrong with the data. How are you going to do all that? The diagram on the right there is a bit of an application architecture diagram from a tool, and shows a screen, a couple of different forms, one on the web, one not, linking to an application and a report, and underneath the skin there we have links to data definitions. And we have some data movements down the bottom there from database to database, an application using database. That's an architecture. Back, it's a recording. Oh no, the recording didn't stop. Okay, we can create mappings. We have data movements here showing from the source to the target, which happen to be from SAP ERP to this OLTP system of ours. Maybe it's a data warehouse. But on the left hand side we've actually got a diagram showing several databases and the flow of data between them and the detail of the data transformation. So all I'm going to ask you to is to get modeling, build a database of your database metadata, and join the dots to your other stuff. 10 seconds left.